Okay, so this lesson is going over a lot of the same things we did in the lesson 2, but this time I have an even data set rather than an odd data set. So starting out, let's describe what the data is. I've decided I'm going to talk about, or my data set is going to be representing the age of dogs in my neighborhood. And this is just something I'm making up. So the ages of the dogs in my neighborhood, I have, say, 8 dogs in my neighborhood. And one of them is 10 years old, 8, 5, 3, 1, 2, 12, and 7. So these numbers are going to be a little bit smaller and easier to work with than some of the ones in lesson 2. I'm going to start out with mean, variance, standard deviation, and mean average deviation. So I'm going to do that part first because those kind of all go together. And then I will also do the median, the 5-number summary, which includes the minimum value, Q1, median, Q3, max value, range, interquartile range, and box and whisker plot. All right, so that's all what's coming up in this lesson. All right, so once again, to find the mean, you have to take the sum of your values divided by the number of numbers. So again, this is for a population. I'm going to do a separate video for a sample population. So this is, when it's a population, it means that there are exactly this many dogs in my neighborhood, and I am finding the data that goes with that exact value. This is not just a random number of ages of dogs in, say, my whole subdivision. So this is exactly 8 sets of data. Okay, so to find the mean, I would have to add up the numbers. So if I take my 10, my 8, 5, 3, 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, just want to make sure I did have 8 there. 12 and 7, if I add all of those numbers up and divide by 8, the sum of your numbers is 48 divided by 8 gives me a nice whole number 6. If it wasn't a nice whole number, round to the nearest 10th. Okay, so that's my mean. Not too hard. The next thing I'm going to find is my variance. So again, I like to set this data up in a table sort of fashion with different columns. So my first column is going to represent my data, and then I'm going to subtract the mean, or mu, and then I'm going to take those values and square it. So I'm going to start with I do recommend that you order your data from smallest to largest. So my smallest piece of data is 1, and my next smallest is 2. The next one is 3. And I'm just looking at these numbers here. So we've got 1, 2, 3, 5, 7, 8, 10, and 12. So I'm just count 1, 2, 3, 4, 5, 6, 7, 8. Always a good idea to check to make sure that you have all of the pieces of data. So now I'm going to subtract my average, which is 6, from each of these. And then after I subtract it, I'm going to square those values. So if I take the difference between, or 1 minus 6 is -5. I'll square that in a minute. 2 minus 6 is -4 squared. 3 minus 6 is -3 squared. 5 minus 6 is -1 squared. 7 minus 6 is 1 squared. 8 minus 6 is 2 square that. 10 minus 6 is 4 12 minus 6 is 6. All right, so now when I square these values, they will all be positive numbers. So 25, 16, 9, 1, 1, 4, 16, 36. All right, so now to continue finding my variance, I have to take the sum of the squared differences. So when I add those up together, the 25, 16, 9, 1, 1, 4, 16, and 36, I do get 108. And then I divide that by the number of numbers that I have, n, which is 8, and I get 13.5. So that is what you would have used for your variance. All right, so now the other two items that you're asked to find is your standard deviation and the mean average deviation. So the mean, let's do the standard deviation. So the standard deviation basically tells you how much the data shows or describes or gives a value that represents a value that represents how much the data varies from the mean. So the value that represents how much the data varies from the mean. So if you have a very large standard deviation, or if your numbers, if you have a large standard deviation, that means the data is really spread out. If your standard deviation is rather small, that means your data is pretty close together. But your standard deviation is basically, or SB, is just the square root of your variance. So since my variance is 13.5, if I take the square root of 13.5 and round to the tenths, I get 3.7. So that is my standard deviation. The mean average deviation is very similar, but it's not quite as time consuming. Because that is the absolute value, or the sum of the absolute values. All right, so sum of the absolute values of the differences, and then divided by your number of numbers. So if I look back where I was subtracting the data minus my average mean, which is 6, I would have these numbers: the -5, -4, -3, -1, 1, 2, 4, and 6. So actually I'm going to do the mean average deviation over here. So when you're doing the mean average deviation, you don't need to square it, but you just need to take the absolute value, so which basically gets rid of the negative. So the absolute value of -5 is 5. The absolute value of -4 is 4. The absolute value of -3 is 3. The absolute value of -1 is 1. Absolute value of 1 is 1. Absolute value of 2 is 2. 4 is 4. And 6 is 6. So you take the sum of those values and divide it by 8. So the mean average deviation, then, if I take the sum of those, the absolute values of those differences, I get 26 divided by 8, which is 3.25. So your standard deviation, let me try to zoom out here a little bit. There we go. So your standard deviation was 3.7. Your mean average deviation is 3.25. So those numbers do tend to be very close to each other. but one is a little bit easier to find than the other, and there are different uses for different things. So anyway, so that's our mean, variance. So we talked about mean, variance, standard deviation, and mean average deviation for a population set. All right, so the next thing I'm going to do is using the same data, I am going to find the median, quartiles, interquartile, and complete with the box and whisker plot. So I'm going to go back to my other page here, go to the next page. All right, so on this page, I'm going to have the same data. Which again represents the ages or the age of the dogs in my neighborhood. Okay, I can't spell. And again, I want to put them in order. So 1, 2, 3, 5, 7, 8, 10, and 12. So I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So that's why it's an even data set example. So I'm going to find in this, let me just put up here, I'm going to find the median. We're going to focus on the median, the range, your Q1 or the lower quartile, Q3 your upper quartile, the interquartile range, and our box plot, which comes from our 5-number summary. So these are the things that we're going to be discussing right now. All right, so when you have an even set of data, you do not have an exact middle. So since there's 8 pieces of data, the middle 2 numbers are going to be the 4th and the 5th piece of data. So there's 3 numbers below, 3 numbers above. The 4th and the 5th piece of data is 5 and 7. So your median is the sum or the average of those 2 numbers. So the median is going to be 5 plus 7 over 2. So your median will equal 12 divided by 2, which is 6. All right, so that's your median. When there's an even set of numbers, you have to take the average of the 2 in the middle. The range. So your range is basically the maximum value minus the minimum value. So your maximum value is 12 minus your minimum value is 1, which is 11. So your range is 11. All right, so that was pretty easy. Your lower quartile, which we also call Q1, is the median of the lower half of the data, or the data below the median. So if we look at since we have 8 pieces of data, there are exactly 4 pieces of data that are to the left and 4 to the right. So your lower quartile will be the median of the lower half of the data, which is 1, 2, 3, and 5. So if I find the median, again, there's an even set of numbers, so I have to find the average of those 2 middle numbers. So 2 plus 3 is 5 divided by 2, so Q1 is going to equal 2.5. So that's my lower quartile. My upper quartile which again is represented by Q3, is the median of the upper half of the data. So again, since we have an even set of data, there's exactly half of the numbers that are above it. So 7, 8, 10, and 12. And since, again, there's an even number of numbers, I have to find the average of my two middle numbers to find the median of those upper numbers. So 8 plus 10 divided by 2 is 9. So the upper quartile, or Q3, is 9. So let's see, if I zoom out here a little bit, did I find everything that I was looking for? I've got my median, I've got my range, Q1, Q3, oh, interquartile range. So let me do that over here. Okay. So your interquartile range is Q3 minus Q1. So my Q3 is 9, my Q1 is 2.5, so my interquartile range is 6.5. So that basically talks about how spread out the middle part of the data is. All right, so zoom out here. So now we just need to do the five number summary and the box plot. So your 5 numbers, again, come from the minimum, Q1, the min value, Q1, median, Q3, and max. Make it a little bit bigger here. Scroll down. Okay, so our 5 number summary starts with our lowest number, our min value, which was 1, our Q1, which is 2.5, our median, which was 6, our upper quartile, or Q3, which was 9, and the max value, which is 12. So min, Q1, median, Q3, and max. So since our range is 11, and we have to go from 1 to 12, I'm going to suggest that when we're making our box plot, that we use an axis. Remember, leave some space above this axis. I'm going to start at 0. And since I'm just going from 1 to 12, I'm going to go by units of 2, or intervals of 2. So 0, 2, 4, 6, 8, 10, 12, and I'll just put 14 on there, even though we don't need it. So there's my axis. Now, when we make our box, we use our Q1 and our Q3. Oops. So Q1 and Q3. So 2.5, let's see if this is 2 and this is 4, 3 is halfway, so 2.5 is about right here. So that's a vertical line for my left side of my box. The 9 is halfway between 8 and 10, so up here, fill in the box. All right, so that's the box that goes between Q1 and Q3. Then you draw a vertical line in the center representing your median. So this is our median at 6. Then we put points on the minimum and maximum value. So 1 is my min, and then our whisker. And then our max value is 12, and our whisker there. So min and max. And what we have now with that box and whisker plot, again, it represents your range of data. So 25% of your data would be between the minimum and Q1. 25% of your data is between Q1 and the median. 25% of your data is between the median and Q3. And 25% of your data is between Q3 and the max. Okay, so there's one more thing that I would like to do, and that is to talk about the difference between sample variation and sample standard deviation, but I'm going to do that in the next lesson.